Hello everyone, I am Divya, your math facilitator. So we are going to start our revision classes for TS, so Telangana Students Class 10 Boards 2022. Now the aim of these revision classes is to help you score the maximum marks. So apart from your internal marks, so you are going to attempt the paper for 80. So out of this 80 marks, you need to score the maximum, and along with your internal marks out of 100, I wish that you score more than 80 in your maths exam. So this is the agenda of these revision classes. Okay, so if you are not considering the revision classes, then the score should be at least 60 marks out of 80. So I am using the word at least. Okay, so if you are following these classes even in the last minute, so you should be able to score at least 60 marks. Okay, out of 80. So this is the agenda. So let's begin the session. Now before I begin the session, let me tell you from where did I choose the questions for your revision classes. So Telangana government has prescribed a material for you which is called Abhyasa Deepika, which most of you know and some of you don't know even now. So Abhyasa Deepika is given by TS government to help you score more and more. So in Abhyasa Deepika, you have the questions but you don't have the answers in it. But here we are going to discuss the question as well as the answer, and I have divided the material as per your convenience. Okay, so we are going to learn objective type in one session, short, very short and essay questions. So accordingly, this would be the plan for most of the chapters. Now if I have to talk about chapter number 1, so in chapter number 1 we have two major topics, that is, first part is you have real numbers and the later part is logarithms, which is completely different topics. So I have divided this into two parts, that is exercise 1.1 to 1.4, that is still these topics, that is Euclid's division lemma, LCM and HCF, fundamental theorem of arithmetic, division, decimal expansion of your rational numbers. Okay, so till here we have divided it as part 1. So in these four topics, okay, so you will be learning of how to solve your objective short, very short and essay questions as well in these four topics. That is from exercise 1.1 to 1.4. Now exercise 1.5, which is logarithms, will be dealt separately in our revision sessions. Okay, so this is the plan for the next 10 to 12 days. So I wish everyone will attend each and every class, because in every class we are going to discuss only and only the important questions. Now if there are any new students who are joining the channel for the very first time, and if you want to check the credibility of the channel, that is if you want to know whether really the channel will help you in your board exams, then let me tell you. So you can go check the channel. You have a lot of feedbacks from the students. So Maths Facilitator has backed a lot of ranks in your polycet entrance examination as well, not only in board exams. Let me tell you, in your polycet entrance exams, in your triple IT. So there are students who have learned only from our channel and gained seats in triple IT Basara as well. So you can check it out. So in YouTube shorts of our Math Facilitator channel, you have the feedbacks. You can also see my Instagram profile. So there also I have shared the comments, the feedbacks of students who have learned from our channel. So you can check all of them and then follow the revision classes, so that you have confidence that you can score more and more by watching our revision classes. Okay, so this is short introduction about what we are going to do in the next 10 to 15 days, so that we score more, and also why you have to trust us, because already there are almost 1 lakh students who have been trusting us since last year. Last year schools have even not started last year. So within 1-2 months, we were able to score so many ranks in polycet, so many 10 or 10 points in board exams, and also triple IT Basara seats. So this is, the achievement of our channel Math Facilitator. So you can have a look of all of them in my Instagram profile if you cannot, search in YouTube channel, because you have a lot of videos, I know. If you're not able to search also, if you don't have the patience to search also, you can just visit my Instagram profile. You have only student feedbacks, and you can check out there also with their ranks. And if you have little time, you can search my YouTube channel also. Under every video, you will see the comment section. Under every SA1 revision classes of this year also, you can see the comment section. You can see how many students have given the positive feedback that the same questions repeated, whatever we have taken in the revision classes. Okay, now since it is the very first class, I'm giving you such a big introduction because you need to know about the channel and you need to have trust. Only then you can follow the channel properly and you can score well, right? So without trust, you cannot learn anything from here, right? So that is the reason I have been discussing all these points with you. Okay, then let's begin the session. So the very first question is from Euclid's division lemma. So Euclid's division lemma is nothing but if you are dividing a number, okay, by any other number, provided so your a is less than b, that is your divisor is less than your dividend, so you get a quotient and a remainder, isn't it? So the remainder is always less than your divisor, or it can be 0. So r can take values from, okay, so I have taken it as a here, so here I can write a. Otherwise, if you want your textbook notation, you can write it as a and b. So where you will have it as, okay. So let me repeat it. So if I have a number a, which is dividend, so I can divide this number by b, which is called divisor. Then I get a quotient and a remainder. Now this remainder is always, it can be 0 or it is always between 0 and b, that is your divisor. For example, if I take 7 divided by 2, where you can see this 2 is less than 7, okay, always your divisor is less than your dividend, then you get a quotient. So 2 3s are 6 and you have a remainder. Now this remainder will always be less than your divisor, divisor is 2. Okay, so remainder will be less than divisor, and in some cases you get remainder as 0 also. So remainder varies from 0 to b. Okay, it can be equal to 0. Remainder can be equal to 0. Okay, so it can be equal to 0 or it is less than this way. It is in between 0 and b. So combining these two, you can actually state it as this. Okay, so this is about Euclid's division lemma. Now, using Euclid's division lemma, you need to find the HCF of 36 and 48. So Euclid's division lemma, if you are repeatedly using, that is called Euclid's division algorithm. Okay, so using that you need to find the HCF of these two numbers. Okay, so if they are asking you what is the benefit of Euclid's division lemma, it is used to find the HCF of any two numbers. Okay, so what do we do now? So I told you Euclid's division lemma is nothing but dividing two numbers, isn't it? You get a quotient, you get a remainder. So suppose we have taken this example, isn't it? Okay, so here 2 3s are 6, I get a remainder. Now can I write 7 is equals to 2 into 3 plus 1? Okay, the same thing, let me write it here. So let me take a different color. So if this is B, this is A, this is quotient and this is remainder. Okay, this is, okay. So I have taken dividend as A, divisor as B, just to use your textbook notation. Otherwise, these are variables, you can write A, B, C, D or X, Y, Z, any which ways. It will be correct, okay, but you should know what are you representing with what. A is dividend here in this case, B is divisor, Q is quotient, R is remainder. So I can write my dividend is equals to, A is equals to divisor into quotient plus the remainder, isn't it? A is equals to 7 equals to 2 into 3 plus 1, that is what I have written. 7 is nothing but A, 2 is nothing but B, 3 is nothing but Q and R is 1. Okay, so this is nothing but Euclid's division lemma. So repeating it again and again, you will get a Euclid's division algorithm by which you will find HCF of these two numbers. So what is the first step you have done? You have to divide. Only then you will know what is quotient and remainder. So here also let's divide these two numbers. So 36 and 48. Always the smaller number will be your divisor, the bigger number will be your dividend. So 36 only one time it will go in 48, so you have again 36. So 12 is a remainder. Now your remainder is less than divisor, so you can stop it here. Okay. So this step, how can I write this step using Euclid's division lemma? So can I write 48 is equals to, 48 is nothing but the, yes, 48 is nothing but the dividend, isn't it? Here it is dividend is equal to divisor into quotient plus the remainder. This is how you can write. So 36 into 1 is 36 plus 12 gives you 48. Now in the next step, what happens in the next step is, This 36 will be the new dividend and this 12 will be the new divisor. Did you understand now? Okay, so you will leave the quotient. This 36 will be new dividend and the remainder will be the new quotient. So 36 is equals to, so dividend is equal to divisor into, now I need to find a quotient plus the remainder, isn't it? A and B you already have, these are A and B. So after dividing you will get the quotient and remainder. So after finding you can write. So let us do it now. So here always do remember the smaller number will be outside, the bigger number will be your dividend. Okay. So 36 how many times you have to take in 12? So 36 is 3 times. 12 3s are 36. So you get the remainder as 0. Okay. So can I write this as 36 equal to 12 into 3? 36 is nothing but 12 into 3 plus 0. Now that's the end of the question. So wherever you get the remainder as 0. Okay. So have a look. When remainder is 0, so whatever is your divisor value, okay, that is B value. So that will be your HCF. Okay, so when remainder is 0, you take B as 12. So that is therefore HCF you can take it as 12. Okay, so comparing here you see this is A is equal to BQ plus R. So when R is 0, so whatever is there in the place of B, that will be your HCF. Did you all understand now? So until you get R as 0, you will just repeat the same step. Okay. So if it was not R as 0 here, you will go to the next step again. How will you go to the next step? In next step, this 12 will be the divisor. Whatever remainder you have, that will be the dividend. And again you will divide, you will write the quotient and remainder. Okay. So see here, this 48 is the dividend, 36 is the divisor. So dividing, I got a quotient, a remainder. So this quotient will be the next dividend. This remainder will be the next divisor. Okay. So 36 will come first, 12 will come next. And after dividing again, you know, quotient is 3, remainder is 0. So whenever R is 0, this value of B is your HCF. Is it very clear to everyone? Now before I proceed to the next question, let me tell you. So after discussing Abhyasa Deepika questions, I will also give you previous year important questions. Okay. Now the notes of all of this, Abhyasa Deepika, these questions you don't have to worry. I'll just share all of this in mathfacilitator.com website. Okay. Mathfacilitator.com website. So you can go and check timely. So I'll update all the material there relevant to your board exams. So you can check all the chapters, your essay questions, objective type also. Every chapter minimum 20 questions I'll discuss with you. Every chapter. So 20 into 14 minimum 280. And also your previous year PYQs also I'll discuss. PYQ, previous year questions of objective I'll discuss. So minimum 300 to 400 questions let's do for objective type also. Okay. So all the notes I'll be sharing in mathfacilitator.com website. And also as I told you, after this chapter again you will have one more class of previous year questions of real numbers chapter. Okay. So I'll give you those questions also for more and more practice. Right. So let's proceed to the next question now. Okay, let's proceed to the next question. Find HCF and LCM of 80 and 120 by prime factorization method. So previously we have learned how to find the HCF of two numbers given in Euclid's division algorithm method. So now we are going to learn in prime factorization method. In Euclid's division algorithm, we divided the numbers, right, and we wrote it in the form of dividend equal to divisor into quotient plus remainder, that is A equal to BQ plus R. Now here we are going to prime factorize the given numbers first. So how do you do that? So 80, let's prime factorize. 120 also, let's prime factorize. Okay. So prime factorizing 80 and 120. What is the answer I am going to get? Have a look now. So 2 times I am taking, so it is 40. Again 2 times, so it is 20. Again 2 times, 2 tens are 20. 2 fives are 5 one time. So 80 I can write it as 2 into 2 into 2 into 2 into 5. Or I can write as 2 raised to the power 4 into 5. How many times I have to? 1, 2, 3, 4. So 2 raised to the power 4 into 5. Now 120 I can write as again 2 I am taking. So 2 60s are 120, 2 30s are 60, 2 15s are 30 and 3 5s are 15 and 5 1s are. Okay. So 120 I can write. Now this is 80. So 120 I can write it as 2 into 2 into 2. So I am writing it as 2 cube into 3 into 5. Till here I hope it is clear for everyone. Now I need to find the HCF. So to find HCF, okay, so always remember to find HCF, the trick is, the first step you will do is take only the common factor. Okay, to find HCF you will choose only the common factor. Second step is you will choose the smallest power of the common factor. H means highest, so the reverse of it, you will choose smallest power. Okay, so firstly let us find what is the common factor. This is the first step, second step. Do remember, only 2 steps you have. So a lot of students have confusion here, so I am repeating the steps. First step is just take the common factor. For HCF you should take only the common factor. So here you can see 2 is the common factor. Okay, so let me write 2 here. 2 is a common factor, so I am writing 2. What is the second step? From the common factor, you will choose the smallest power. I have 2 power 4, 2 cube. So which is smaller? 2 cube is smaller. So I am writing 2 cube. Now check, is there any other common factor? See, 5 is also a common factor. So write 5 also. 5 power 1, 5 power 1. So powers are same, so you don't have to choose anything. So 2 cube into 5, that is 8 into 5. 2 cube is nothing but 8. 8 into 5 is 40. So 40 is the HCF. Clear? Now if I want to take the LCM, now let me tell you what is the rule for LCM. For LCM, okay, the first rule is you will take all the factors. All the factors. Second rule is, okay, wherever if you have any common factor, there you will choose the greatest power. Okay, so what is the first rule? You will take all the factors. Now here I told you will take only common factor, HCF. So only common factor you will take. And H means highest, so the reverse of it, you will take smallest. Okay, you will choose smallest. Here you will take all the factors, and wherever you have any common factor, you will take the greatest. Now have a look here. Now 2 is a common factor. Okay, so I am writing 2. So 2, when a common factor comes, you will choose greatest power. So out of 2 cube and 2 power 4, which is greatest? 2 power 4 is greatest. So write that. And next, see, 5 is a common factor, but 5 power is same, so I am writing it as it is. So when the power is same, you have nothing to choose, isn't it? When there are different powers only, you can choose which is greater, which is smaller. If both are same, you cannot choose anything, so you can write it as it is. Now, should we leave 3? 3 is not a common factor, but you have to take all the factors. So you have to write 3 also here. Okay, so this is nothing but 2 power 4 is 16 into 5 into 3. So how much do we get here? How much are we getting here? 16 into 15, or you can write it as 16 into 5 is nothing but 80. So 80 into 3 is 240. Did you all get the same answer? Right? So this is how you do. So whichever question is given to you, firstly prime factorize if they are asking prime factorization method, and then take these 2 rules. Make a note of all these 2 rules. For HCF, what are you taking? For LCM, what are you taking? Okay, because students have confusion. Why are we taking few factors in HCF? Why not in LCM? And why in LCM? Why not in HCF? So this is the rule. Okay, so you can remember these 2 points so that you can get full marks. Right? So let's proceed to the next question now. Okay, the next question, if HCF of 90 and 144 is 18. Okay, so it is given HCF of these 2 numbers. Which 2 numbers? 90 and 144. HCF of these 2 numbers is given as 18. Okay, which is HCF is nothing but 18. The numbers are, I am taking the numbers as one number as A, the other number as B. Okay, so you have to find the LCM. So how do you get the LCM? So simple formula which you have learned in your lower classes. You know that product of HCF and LCM is equal to the product of the 2 numbers. Okay, so product of HCF and LCM is equal to the product of the 2 numbers. So using this you can find your LCM. So HCF is 18, LCM we don't know. So that is equal to one number is 90, the other number is 144. So LCM is equals to 90 into 144 divided by 18 you get. Okay, so here 18 is in multiplication, transposing to the other side, so it is divided by 18. So 9 2s are 18 and 9 10s are 90, and 2 1 time, 2 I can write as 72 times. Okay, so 144 72 times. So here your final answer would be LCM is nothing but 10 into 72, so you get 720 here. Is it very clear? So this simple formula you will have to remember, right, which you have learned in your lower classes. So let's proceed now to the next question. So next question is here, express 2 to 5 as product of prime factors. So product of prime factors, to express it as prime factors, firstly let us prime factorize this. Okay, so even if you don't do this, everyone knows 225 is 15 square, you can do that way also. But I'm telling you the best procedure which everyone can do without any mistake. Okay, so I'm just taking 5 table, okay, because I can see 5 is in unit place, so it is divisible by 5. 5 4s are 20. Out of 22, if I subtract 20, I have a 2, so this is 25. 5 5s are 25. Again, 5 9s are 45. 3 3s are and 3 1s are. Okay, so 225, I can write it as 5 square into 3 square. So this is product of prime factors. Very simple question which you can get for very short answers. Okay, so let's proceed to the next question now. So have a look at the next question. This is actually essay question. Okay, 4-marker question. So I just want all of you to listen very carefully, because whatever we are going to do here, so you may get the same model. Okay, if you are getting the same model also, you should be able to do. Now what are we going to do here? Show that the square of any positive integer. You have to show that the square of any positive integer, okay, square of any positive integer is of the form 5m plus 1 or 5m plus 4. Now do you remember, this is your first exercise, very first exercise. This is question from the first exercise, Euclid's division lemma concept based question it is. Okay, so how do we proceed here? So you have to show that the square of any positive integer is of the form 5m plus 1, 5m plus 4. Okay, so firstly, square of any positive integer. So let me take the positive integer. So square of this positive integer I want. So firstly, let me just assume, okay, let the positive integer, I am taking it as a. Okay, in Euclid's division lemma, you know it is a is equals to bq plus r. Okay, so I am taking the positive integer as a. So this a, you have to show it is of the form bq plus r. A is equal to bq plus r. In the place of bq plus r, you have 5m plus 1, 5m plus 4, 5m. 5m, I can write it as 5m plus 0, isn't it? 5m, I can write as 5m plus 0. Value will not change. Adding 0, the value will not change. So 5m plus 0 I can write. This is 5m plus 1, 5m plus 4. If you clearly observe, it is like bq plus r. See here. It is like, so it is like bq plus r. This is like bq plus r. This is like bq plus r, isn't it? You have to show that any positive integer, square of any positive integer is of this form. Now I have taken the positive integer as a. Now square of this a, if I am squaring this a, I should say that it is of 5m plus 0, 5m plus 1 or 5m plus 4 form. Isn't it? That is the meaning of the question. If you compare, now here in the place of b, you actually have what? You have 5. See, in the place of b, I have 5. In the place of b, I have 5. Here also in the place of b, I have 5. So can I take b equal to 5 from the question? So whatever is given to you in the question, you will compare it with Euclid's division lemma, and in the place of b, whatever you have, that you will take it as, okay, b value. Okay, so let the positive integer, I am taking it as a, and okay, b I am taking it as 5. How did I take this value? From the question. If it is given as 3m plus 1, 3m plus 4, then b will be 3. Okay, it will be 3. So you have to just compare it with this. So this is, you can write it in your rough work. Okay, so now b is 5. So if b is 5, what is the condition for Euclid's division lemma? What about the remainder? Remainder can be 0, or it can be somewhere between 0 to less than b, isn't it? It has to stop at b. Less than b it has to be. So if b is 5, okay, then Remainder will be 0 less than or equal to r less than 5. In the place of b, what do you have? It is 5. So it is 0 less than or equal to r less than, instead of b you wrote 5 because you know b is 5 from the question. Okay, so this condition means that so r can be 0, it can be r is equal to 0, or it can be 1, 2, 3, 4. Can I take 5 also? I cannot take 5 because r is less than 5. Less than 5. Less than 5 means you have to stop at 4. Okay? Less than 5 means you have to stop at 4. Is it clear? Okay? So this is how you take all the values. Now once you take the values, so let's proceed to the next point now. So therefore, can I write using Euclid's division lemma, can I write A is equals to BQ plus R? Isn't it? But here A is equal to, in the place of B I have 5. So I can write as 5Q plus R. Okay, so this will be your first equation. Did you all understand? So I have taken the positive integer as A, B value as 5 from the question. So if B is 5, R will be between 0 and 5. So these are the values of R. And substituting in Euclid's division lemma, so that is what we have compared, isn't it? So A equal to BQ plus R. So A is 5Q plus R. Okay, now you can see R has different values. So for each value, let us take one case. Okay, if I am taking case 1, so I will consider firstly R as 0. Okay, so if R is 0 is the first case, R1 is the second case, R2 third, R3 fourth, and R4 is the fifth case. So 5 cases you will have in this question. So if R is 0, so equation 1, what does equation 1 become? It becomes A equal to 5Q plus 0. Isn't it? Because R is 0, it will become 5Q plus 0. Or I can write A equal to simply 5Q. Okay, but did we get the answer? So most of the students here, they feel that we need 5m. So here I have A equal to 5Q, so I got the answer. But no, you did not still get the answer. You have to find square of any positive integer. That's what I said. So A square I need to find. Isn't it? Square of the positive integer, I should show it is of the form 5m, 5m plus 1, 5m plus 4. So that is the reason I asked you to write in rough work there. So now let me square. Why am I squaring? Why I will square on both the sides? Because in the question they are asking me square of any positive integer. Now suppose in the question if they ask you cube of any positive integer, then what do? In this step you will have to write cubing on both the sides. If they are asking square, you will square. If they are saying cube, you will cube on both the sides. Okay. Now since it is only square, I am squaring it on both the sides. So A square equal to 5Q whole square, or I can write A square is equal to 5Q whole square. Can I write as 5 into 5Q square? Now you might be wondering why have we written it as 5 into 5Q square. 5 square, Q square it is. 5 square I can write as 5 into 5 and Q square I wrote it here. Now the only reason why am I doing this is I can write this total 5Q square as m. Okay, so let 5Q square I am taking it as m. Why? So that I can bring it in the form of 5m. Okay, so square of any positive integer is of the form 5m. Is it clear to here? Is the board visible to you? Right. Okay, so this is equal to. Okay, so now this is case 1. Now let us take case 2. So what happens in case 2? I will take if r is equal to 1. I have completed 0. Now I will take 1. Okay. So if r is 1, equation 1 becomes, this equation becomes 5q plus 1. In the place of r, I substitute 1. Now what do we need to know? I want square of the positive integer. So let's square on both the sides. Okay, I am squaring on both the sides. So a square is equals to, it will be 5q plus 1 whole square. This is like a plus b whole square. So I can write as a square plus b square plus 2a into b. Okay, 5q square is a square plus 1 square is b square plus 2 into a into b. So that is equal to, I can write as 25q square plus 1 plus 10q. Okay, 5 2s are 10q. Now here I can write, see here, 25q square and 10q have something common. 5q I can take common. So I'll write this 25q square plus 10q together. This one I'll write it at the end. Okay, because you have 1 at the end for the second case. So here, as I told you, what do we want? We want 5m plus 1. So I'll just take only 5 common. Only 5 common because I want it like 5m. So only 5 I'll take common. So here I'll have out of 25. Out of 25 q square, you can write 25 as 5 5s are. So 5 q square. So if I'm taking 5 common, what is left over? 5q square plus here 10q. Out of 10q, if I take 5 common, 2q is left over and plus 1. Only from these two we are taking common. From 1 you cannot take 5 common, isn't it? Here I am taking common because 10 also I can write as 10q, I can write as 5 2s are, and this q I am writing. So if I am taking 5 common, I will have 2q. So that's what I wrote. Now here in the last step, you can actually write this is 5 into m plus 1. How did I write 1? Now in this case, this total I can take it as m. So let 5q square plus 2q, I am taking it as m in the final step. Okay, so therefore square of any positive number I got as 5m plus 1. Is it very clear? So here we have proved the second case also. Now let us proceed to the third case. Okay, case number 3. So is the last step visible to you people? Okay, now I hope it will be visible. So case 3, let's do case 3 now. So in case 3, you will take if r equal to 2. Okay, if I am taking r is equal to 2, so substituting in the first equation, a will be 5q plus in the place of r I will write 2. Now what should I do? I should square on both the sides. So I'll have a square equal to 5q plus 2 whole square. See, the same steps we are repeating again and again. Only that you will see the question, whatever you want in the question, you will just adjust here. I want 5m. So only 5 I am taking common, this total I will write as m. I want 5m plus 1. So this plus 1 I am taking to side, and here out of 25q square and 10q, I will take only 5 common because I want 5m plus 1. So this total value will take it as m. So little you will have to, use little common sense, that's it. So there is nothing to by heart in the question. There is nothing to, worry about the question. It looks lengthy, but it is easy. The same step here you have done, here you are doing, and here also you are doing. And the next cases also you will do the same. Okay, so this is 5q whole square, a plus b whole square, plus b square plus 2ab. So I can write a square is nothing but 25q square plus 4 plus, can I write that as 5 2s are 10, 10 2s are 20, so 20q. Now I need to write it in the form of 5m plus 4. See, plus 4 I got here. Okay, so this I will write it at the end. So I can write a square equal to 25q square plus 20q plus 4. Now I need, see, plus 4 I got. Now this I have to write in the form of 5m. So I will take only 5 common from these two, because I have to write in the form of 5m. So out of 25q square, if I take 5 common, just now also I told you how much you will have, 5q square you will have, plus out of 20q, if you take 5 common, so 20 I can write as 5 4s are, I have q. If I am taking 5 common, I will have 4q remaining, plus 4. Okay, so then what I will do, the last step, I will write this total value as m plus 4. So let, in every step, whatever you are taking it as m, you have to write it here. Okay, the reason is if you don't write it here, in the previous step you have taken this as m, in this step you have taken this as m, so there will be confusion. Here you will have to mention that now in this case this total is m. Okay, in this case this total is m. So if you don't mention in bracket, you will lose marks. Okay, so please do mention. So here I got the third case also. So in first case I got 5m, second case 5m plus 1, third case 5m plus 4. So all the cases are satisfied. But still, since it's a essay question, I suggest you do it completely. So complete the remaining 2 cases also. You have only 2 cases left. So please do the remaining 2 cases. So how will you do? Let me do case 4 now. So if r equal to 3, I completed r equal to 2, now I am doing r equal to 3. So a will be bq plus 3, isn't it? bq plus 3. So now squaring on both the sides because the steps are same actually. So if you are doing 1-2 cases extra also, you will gain marks, you will never lose marks. So a square will be equal to 5q plus 3 whole square. So it is a plus b whole square. So I am directly writing a square plus b square plus 2ab. 2 into 5 is 10, 10 into 3 is 30. Okay, so 2ab, a square plus b square plus 2ab value is this. Okay, so now that is equal to, again, see here. See here, what do we need? We need to bring it in the form of either 5m, 5m plus 4 or 5m plus 1. 5m plus 1 or 5m plus 4. So here if you see, I am writing this as always this constant, let me transpose it to the end. I have written it to the end. But this 9 is actually greater than your b. B is only 5. Okay, so this 9 is greater than b. So what you will do is, you will try to split this 9, okay, in terms of 5 and whatever is remaining. What is remaining? 4. So you will write it here. So 9 I can write as 5 plus 4, isn't it? So this step is really important here. So here I will write as 25q square plus 30q plus 9 I am writing it as 5 plus 4. Now see, plus 4 is something which you have here in the question. So now from this total I want what? 5m I want. Okay. So I'll take 5 common. So here 25q square. If I take 5 common, it is 5q square plus 30q. If 5 is common, 5 6 are 30 and you have q plus 5 is common. So I can write 5 1s are 5. So 1 is remaining plus 4 is there. So that is 5 into this total I can take it as m plus 4. So a square again I got as m plus 4. So here let m is nothing but 5q square plus 6q plus 1. Similarly, if you take case 5, in case 5 what do you do? If r equal to 4 I take. So 3 is done, now I take r equal to 4. So a will be equal to bq plus 4. So if I square it on both the sides, what happens? A square will be equal to 5q plus 4 whole square. Or I can write as 25q square plus 16 plus 2 5s are 10, 10 4s are 40q. So here 16 is also, this constant is also greater than 5. So 16 I can write it as, how can I write 16? See, 16 if you divide by 5, how much do you get? 5 3s are 15, isn't it? I can write it as 15 plus 1. Why am I dividing it by 5? So this 15, I will take 5 common from this 15. Okay. So here also we have done the same thing. So 9, if I am dividing 9 by 5, I have 5 1s are 5 and 4 is remaining. So if I take 16, so the quotient will be 15. 5 3s are 15 and 1 will be remaining. So the same thing we are going to do here. So I can write this as 25q square plus 40q. This 16 I will write as 15 plus 1. So this plus 1 you can see in the second case you have. So out of these you will take what? So now you will take a square equal to 5. I will have 5q square plus 5 8s are 40q plus 5 3s are 15. Did you understand why did we take now? So 5 3s are 15 I can write plus 1. So this total I will write it as m plus 1. So again a square you are able to get as 5m plus 1. So all the 5 cases are really important. Is the last step visible? Right. So all the 5 cases are really important. You just need to do all the 5 cases because it is a 4-marker essay question. Okay, and you should understand if this value, okay, this constant is greater than b, you have to split. How are you splitting it? You have to split it such a way that when you split, so this will be your remainder and this you can take common here. So here also you see. Now 16 I have split it as 15 plus 1. So that from 15 also I can take 5 common and this one will be the remainder. Understood? So this splitting is really important, right? So essay question from this is expected. So I suggest you all to do it again one more time. So all the 5 cases, okay, and it is just a repetition. Whatever you are doing in case 1, same you will do in case 2, and whatever you are doing in case 2, exactly same you will do in 3, 4 and 5. So please make a note of this and please do learn. Okay. Okay, now the next model question is you have to show an irrational number is an irrational number. Okay, so which is nothing but proof of irrational numbers. So do you remember you have root 2, root 3, root 5. So all of this is one model. Okay, so let me tell you. So root 2, root 3, root 5, if you learn one, you can do any of this. This is model number 1. If I take model number 2, it is like 5 plus root 3, 2 minus root 7. This is model number 2. If I take model number 3, it is like root 3 plus root 5. Root 2 minus root 3. This is model number 3. Okay, and model number 4 is nothing but it is like 1 by root 2, or you can write it as 1 by root 5, 1 by root 7, or 2 by root 7. So something like this is model number 4. Now model number 5 is, see, you can write it as 2 root 7. So 3 root 5 or 3 root, let me take 11 by 2. So something like this. So how are we dividing it into models? It is nothing but, see, only prime number if you have. Okay, so if you have like root of any prime number, so you can learn only one question and the other questions you can repeat the same. Now this model is nothing but one rational number plus a irrational, or if it is like rational number minus irrational. Okay, then you can take this model. If it is like this, two irrational numbers, so plus or minus a irrational number. Okay, so irrational plus irrational or irrational minus irrational, it is model number 3. Now this is like, so rational divided by irrational number model if you have. So rational divided by irrational, or if you have like rational into irrational number. So these two are actually, very similar. So now this is a division of proof of irrational numbers. Now here let us discuss, each and every model separately, because all of them are important. One, you can get it for short. So possibility is this this is a essay question. This is a short. This is again essay. This is again very short or short you can expect. Okay. So I'm writing it as short. So two essay questions here and short. So let's discuss this topic now. Okay, so let's complete the essay question model first, and then let's proceed to the short answer type. Okay, so the first model let me discuss, which is root 2. Okay, so I want to do root 2 is irrational. So for this, the first step, for every question, for all the models which I gave you, the first step is you will assume, okay, so you will assume root 2 is rational. For every question, you will assume root 2 is rational. So if root 2 is rational, root 2 will be equal to a by b, or you can write as p by q also, no problem. Here you can write any variable, you can write as p by q also, or a by b also, no problem. Okay, where p and q will belong to integers and q is not equal to 0. Now from where did I write this condition? This is nothing but your rational numbers definition, isn't it? So these two has to be integers and denominator should never be equal to 0. Definition of rational numbers. Now let us assume, okay, so let us assume that p and q have common factor. Okay, so I'm just assuming that p and q have common factor. Okay, and simplifying or cancelling the common factors, we get a and b. Okay, that means root 2 I can write as a by b. Now what is the meaning of the statement which I wrote? So for example, if I have 12 by 16, this is like p by q. Here you can see this has common factor 4. I can cancel it. 4 3 is a 12, 4 4 is a 16. So 4 is a common factor. So that is what I told. So if you have p and q, so suppose if they have common factor, like here you have 4, cancelling you will get a and b. So this 3 is like a and 4 is like b. So you can write as 3 by 4. After cancelling this, you will write as 3 by 4, isn't it? So this I am writing it as a by b. So this p and q, if you have any common factors, you are cancelling, you are getting a by b. Okay. So where again a and b. A by b is also integer, isn't it? If you have these two integers, after cancelling also you get integer, and b is not equal to 0. And also one more very important condition is a and b are co-prime. Did you understand? What is the meaning of co-prime? Co-prime is nothing but they don't have any other common factor other than 1. Now for example, 3 and 4 are called co-prime because you cannot cancel it further. There is no common factor. 12 and 16, 4 is a common factor. You can write 4 3 is a 12, 4 4 is a 16. You can simplify it. So here you cannot cancel it further. It is already in the simplest form. No common factor. So such numbers are called co-prime. So co-prime numbers have only one as a common factor. You all know that one is a common factor for all the numbers. Okay. So even if you cancel again with 1, again you will get 3 by 4. So this is the simplest form. Right. So co-prime is nothing but they have no other common factors except 1. Okay. So that means you cannot simplify it further. So here let me write, which means no common factor. One is a common factor, but remember, one is common factor for everyone. So I am just writing as no common factor simply. Okay. So I hope you understood. This is just for your explanation I have written. If you are not comfortable with this, you can just avoid this. Okay. So this is you have to remember in your brain. So that's what I have written here. So with pencil you can just write no common factor other than one. Okay. So few students don't write all these steps, so they directly start from here, from this step. So they say root 2 equal to a by b, where a b belongs to integers, b not equal to 0, and a b are co-prime. So they just start with the statement, they don't write this. But I suggest start from here. It gives much impression when you start from here and much clarification, and it gives an impression that you know the concept very well. Okay, so please do write those first two steps also. Okay, so let's proceed to the next concept now. So I have just written root 2 equal to a by b. Okay, I have written root 2 equal to a by b. Now just cross multiply. So can I write b root 2 b equal to a? Now here I have irrational number. So whenever you have irrational number, what will you do? You will square. So squaring on both sides. What do I get? Squaring on both sides. Okay, so I'll do it here. I'll get root 2b whole square is equals to a square. Or you can write root 2 whole square is 2. So 2b square is equals to a square. Okay, or we can also write this as a square equal to 2b square. Do you all agree? Okay. Now nothing but I wrote this something like, see, one more step I'll write. I am writing it as 2 into b square. A square is 2b square, which is nothing but 2 into b square, isn't it? So there is nothing here, which means it is multiplication product. So now if I write, say, which number should I take? I'll take 6. So 6 equals to, if I write it as 2 into 3, can I say 2 is a factor of 6 and also 3 is a factor of 6? Isn't it? If you are able to write any number as product of two numbers, then each of these numbers are factors of the bigger number. Or you can also say, see, the conclusion I can write 2 is a factor of 6. Isn't it? 2 is a factor of 6. Or I can also write 2 divides 6. What do you understand by this? 2 divides 6 means you can divide this 6 by 2. This 2 is dividing 6. So 2 3s are 6. The answer is 0. Factor meaning this remainder is 0. Isn't it? If you are dividing, you get a 0 remainder. Okay. So if you have any number as product of these two numbers, these are the two statements which I can conclude. One is this is a factor of this number, and also this number divides the actual number which you are taking here. Similarly, can I write the same here? Can I say, see, a square I am writing it as 2 into some number b square. So can I write 2 divides a square? 2 is a factor of a square, isn't it? Compare. 2 into something. So here also 2 into something. So I can say 2 is a factor of 6. So here also I can say 2 is a factor of a square. Yes or no? So therefore I am writing. So therefore 2 divides a square. So there is one theorem which you have learnt. If 2 divides a square, then 2 divides a. If 2 divides a square, then 2 divides a. For example, so see here, 2 is dividing 6. Okay, now what is 6 square? Is 36. So is 2 dividing 36 also? So see here, 2 divides 36. 36 is nothing but 6 square. So then 2 also divides a, that is 6. Okay, if 2 is dividing a square, then 2 also divides a. Right? With the examples I gave. If 2 is dividing 36, which is nothing but a square, so 2 also will divide 6. Okay, so understanding this point, okay, so I have taken the theorem. So here in bracket you will write from the theorem, if p divides a square, then p also divides a. Okay, so therefore can I say 2 is a factor of a 2 divides 6 means 2 is a factor of 6. 2 divides a means 2 is a factor of a. So if it is a factor, now 2 is a factor of 6. So I can write 6 is equals to 2 into some number. So here also 2 is a factor of a. So I can write a is equal to 2 into some number. I don't know what the number is, so I am writing it as. Okay. 2 divides a, which means 2 is a factor of 6. 2 divides 6 means 2 is a factor of 6. So if 2 is a factor of 6, I can write 6 equal to 2 into some number. The same steps here. Okay. So now, let me take this as 2. Let me take this final step which we have taken here before concluding all this as 1. Okay. So now substitute a equal to 2c in equation 1. So what you will have? A is a square you have. So 2c whole square is equal to 2b square. 2c whole square is nothing but 4c square. 2 square is 4c square. 2b square. Or b square you can write as 4c square divided by 2. This 2 transposing it to the other side. So 2 ones are 2 2s are. So b square is nothing but 2c square. So again, something like a square equal to 2b square, you got b square equal to 2c square. So therefore, can I say it is like 2 into c square. So 2 is a factor of b square. Or can I say 2 divides? Okay, directly I write this. So 2 divides b square. Or if 2 divides b square, I can say 2 divides b. Same steps I am repeating. All these are same steps. Okay. If 2 divides b, so therefore can I say 2 is a factor. Isn't it? 2 is a factor of b. So if 2 is a factor of b, have a look now. Here you told that 2 is a factor of a. And then here you told 2 is a factor of b. Which means 2 is a factor of a. 2 is also a factor of b. So can I say 2 is a common factor of a and b? You got 2 is a common factor of a and b. But here you wrote that a and b are co-prime. So here I told you in bracket, do write that there are no common factor. But here you got a common factor, which is wrong, isn't it? So you yourself told that there is no common factor, they are co-prime. Again, you got in your conclusion, in your solving, you got there is a common factor. So therefore, it is wrong. You have arrived at a contradiction. So therefore, it is a contradiction. It is called a contradiction. Contradiction means it is a conflict. Why did you arrive at this conflict? Because you have taken a and b as co-prime. Okay, and here you are writing a and b has common factor, which is wrong. So why did you arrive at this conflict? Because you have taken the first step is as rational. So let us conclude that it is irrational. Okay. Suppose you are standing at a crossroad. You have two ways to go. So this is one way, this is one way. Going this way, you want to go to hospital, and here there is a park. Okay, so you just want to go, or let's say there is a library. So you just want to go to library, okay, to study something, to prepare something. So now here you are standing in the crossroad and you are confused where to go. So you assume that this is a correct path and you start traveling here. Okay, going some distance, you find there is no library here, there is a hospital. So why now this is a contradiction to whatever you want. You want a library but you have a hospital. It's a contradiction. So what do you do now? You now here realize that I have arrived at a wrong conclusion. This is a wrong conclusion. This was not what I wanted. I want this. I have arrived at this wrong conclusion because I have taken the wrong path. The initial step which I have chosen here is wrong. So therefore you conclude that you have to go by this path. The same thing here also. I am standing at this crossroad. I have to prove it is irrational. Okay, and I have rational. Okay, so let's write irrational this side. This is correct and this is wrong. It is you have to prove irrational and this is rational. So you have chosen this path. You have been traveling. You got some contradictions here. Okay, you found that the route, the way you're going is not at all correct, because whatever you have to, in the way, on the way, whatever you have to see here and there. Okay, so suppose on the way you have a bus stop, so you know that you should find all of them on the way. So traveling, you found that there is nothing like that. So which means you concluded that therefore this path is wrong. Now why is this path wrong? Because you have chosen this rational number path, right? So you conclude and say that you have to go this way, so therefore it is irrational. Okay, so always you have to relate maths with your real life, only then you will be able to learn it easily. Now this is model number 1 essay question. Now the same question, if they ask you prove root 5 as irrational. So the same steps, all the steps are same. Only instead of root 2 you will write root 5. Instead of 2 you will write 5. Wherever you find 2 just write 5. Okay. Wherever you find 2 just write 5. All the steps are same. Okay. Here in the place of 2 just write 5. Not in the place of square. Here in the place of 2 just write 5. Wherever you find 2, you have to write what? You have to write 5. So this is also 5. This is also 5. This is also 5. So here also 5. So wherever you find 2, this is also 5. This is also 5. Here 5 square will be 25 here. Okay. And this is 2 square. So you write 5 square. So it will be 25. And here also it is 5. So cancelling again you will get a 5. Again this is a 5. This is a 5. This is a 5. All 2's become 5. All 2's become 5. So you will get the proof of root 5. If you want 7, then all 2's you will write as 7. Okay, so one model, if you are learning one question, you will be able to attempt any question. Root 2, root 3, root 5, root 7, any question you will be able to attempt. So do practice this question once and let's proceed to the next essay question. Okay, what is the next essay question model I gave you? I hope you made a note of all the models which I gave. If not, please make a note. Okay, the next model is rational plus irrational, or irrational plus rational, or irrational minus rational, or rational plus I've written plus, isn't it? So minus irrational. So something like this. Matlab, just understand one rational, one irrational number with plus or minus sign if you have, you will go for this model. Okay, it's also an essay question. So let's discuss now. So for example, the question given in your Abhyasa Deepika is root 2 plus root 3 is an irrational. You have to prove that root 2 plus root 3 is irrational. So first step is I will consider it is rational. Okay, first step I told it is C. So if it is rational, I can write this as P by Q or A by B purish. So where P and Q belong to integers and Q is not equal to 0. Isn't it? Now, whenever you find something like this, so just transpose one quantity to the other side. So root 2 I transpose it to the other side. So I can write this as 3 is equals to root 3 equal to P minus root 2Q by Q. Now, here also you have irrational number, here also you have irrational number. So what shall we do? Shall we square on both the sides? So whenever you have irrational numbers on both the sides, you are squaring on both the sides. So you have root 3 whole square is 3 is equals to P minus root 2Q whole square divided by, I am writing Q square. Okay. So 3Q square. So I am transposing Q to the other side. So 3Q square is equals to, this is like A minus B whole square. So can I write as A square plus B square minus 2AB. Is this expansion clear? A square plus B square root 2Q whole square is root 2Q square minus 2AB. So 2 root 2 PQ. Okay. So this is how we are writing, expanding the formula. Now let's proceed to the next step. So what is the next step? So always remember, in these questions, your irrational number should be on one side. Rational number, try to arrange it to the other side. How are we going to do that? I'll tell you now. See here. So out of this, identify what is the irrational number term. See, root 2. This is irrational number term. So let me take this term to the other side. I have minus, so I'm taking this to the other side. So I'll have it as 2 root 2 PQ plus I have 3Q square here. So 3Q square is equal to, what is remaining here? P square plus 2Q square. Now write irrational number on this side, rational take it to the other side. So 2 root 2 PQ is irrational term, I am keeping it on left side and I will take all the rational term. This I will take it to the other side. So I have P square minus Q square. 2Q square minus 3Q square is minus Q square. And 2 root 2 PQ. Now here also only root 2 is irrational. 2 PQ is rational. So let us transpose this 2 PQ to the other side. So I have root 2 equal to P square minus Q square divided by 2 PQ. Okay, 2pq is in multiplication transposing, you get a division here. Till here, is it clear to everyone? Okay, so now if you have a look, on the left hand side you have a irrational number, on the right hand side you have a rational number. Why is it a rational? It is of the form p by q, numerator by denominator form, and p, q, 2, all of these are integers. Okay, here you can see p, q, 2 all belong to integer, and your denominator 2pq is not equal to 0. So therefore I can say this is a rational number. So left hand side you have irrational, right hand side rational, so this is not possible. So therefore you conclude that this is a irrational number, not a rational number. Okay. So only simple step you have to remember is two irrational numbers. If it is given to you, two irrational number, addition or subtraction, take one irrational number, any one you can take to the other side. Okay, then you will take LCM. Okay, then square it on both the sides. Try to transpose the denominator, and you should remember that your irrational term should be on one side. All the rational terms you will bring it to the other side slowly. Okay, so and then finally you get, because only irrational number on one side I told. So irrational number on one side, you see it's irrational clearly. All the rational numbers you took it to the other side and simplified. So that is rational. So here you have arrived at contradiction. This is one more essay question. So please do try to make a note of it, and whatever question is given to you, you will do it in the same process. Process is same. Okay, and in these two questions, in the first model question root 2 root 5, in that model question you will square on both the sides, and in this model question you will square on both the sides. Okay, no other questions you will square on both the sides. Okay, only these two model questions have squaring on both the sides step. Other questions will not have that. Okay, so I'll show you the other questions also. Right, this model is nothing but rational plus or minus, irrational plus or minus irrational. So two irrational numbers, if you are adding, subtracting, you have this model. So I hope this is clear to you. Always remember, LHS or any one side, left hand side or right hand side, you should have your irrational number. The other side, take your rational number. So you should be comfortable in arranging the terms, right? So let's proceed to the next topic now. So next, let me take the short answer model. Two essay question models we have completed. So where squaring on both sides you have. Okay, now with the short model, suppose if you have 5 minus root 2, you have to prove it is irrational. See, one rational, one irrational. So what do? First step is same. You will consider it a rational number. Okay, so I am taking it as a rational number. Let this is a rational number. Okay, so 5 minus root 2 equal to, I am taking it as a by b. You can take it as a by b or p by q, no problem. The variable you can use anything. Okay, b is not equal to 0. Denominator is not equal to 0. Now, what did I tell you? You should have your irrational number on one side, all rational numbers on the other side. See, this is irrational. So let me have irrational number on one side. Here it is minus root 2. So I'll take minus root 2 to the other side. So it will become plus root 2. And a by b is rational. Let me take this side. So it is minus a by b. Did you understand what did I do here? So 5 is rational, a by b is irrational. So a by b I brought this side, minus root 2 I sent it to the other side because I have minus here. Okay, now if you take LCM, it is 5b minus a by b equal to root 2. Now root 2 is irrational, you all know. This is rational because 5, b, a all are integers, and this is of the form numerator by denominator, which is rational number. So you got irrational equal to rational, which is wrong again. So hence you see 5 minus root 2 is irrational number. Similarly, suppose if I have something like this, root 3 plus 2. You have to prove it is irrational. So how do I do? Take it as a by b again. So only one step. You should have irrational number one side, rational number you are transposing it to the other side. Now take LCM a minus 2b by b. So root 2 is irrational, this is rational, and hence you say that you have arrived at a wrong conclusion because you have taken this as rational. So hence it is irrational. Did you understand? So very simple model. You should have your irrational number one side, rational number the other side. You should arrange in such a way. Now the next model is, I told you 1 by root 2. Okay, or 2 by root 7. So 1 by root 2 you will consider it as rational number. First step is same. So if it is rational number, a by b. You know root 2 is irrational, just reciprocal. So root 2 equal to, you will have b by a, reciprocal on both the sides. So again b by a is also rational. This is irrational. So in one single step you say irrational equal to rational, not possible. So hence 1 by root 2 is irrational. Otherwise, if you have something like say root 3 by root 5, so this also you will take it as a by b rational number. So what did I tell you? Irrational number on one side, rational numbers on the other side. Here root 5 is irrational, isn't it? Let me cross multiply now. So I'll have 3b equal to a root 5. So root 5 is irrational, I'll keep it on one side, and a I'll send it to the other side. So 3b divided by a I'll get, because a is in multiplication here. So this is irrational again, this is rational. So did you understand? So in all these models you don't have any squaring. And one more model, the last model was like 2 root 7. So again you will take it as a by b, root 7 is irrational. So 2 is rational, send it to the other side. Again this is irrational, this is irrational, so which is not possible. Did you understand? All the questions are same. What am I doing in every question? If you see, I am trying to take the irrational number on one side, all the rational numbers I am slowly bringing it to the other side. Okay, so this is all about the chapter real numbers, exercise 1.1 to 1.4. We have discussed all the important questions, essay, short, very short also, and objective I will discuss in the next class. Logarithms we will have a next separate session, as I told you. So where again in logarithms I will discuss short, very short, and essay questions of logarithms, very important questions from your Abhyasika, and also previous year very important questions. I will make one more separate class, so you will watch this class and also solve those questions. And for those previous year questions answers, I'll send it on your math facilitator website. So do follow, you have a follow button, do follow mathfacilitator.com. Just type in Google mathfacilitator.com and you will get the website, or the link I am giving you in the description. Okay, so do click on the link which I give you in description and follow the classes regularly, and all the notes, all the questions, okay, all the objective bits notes and all the previous year questions, everything I'll post it in mathfacilitator.com website. So do click on the link and do follow the blog right now. Okay, so I'll see you all in the next class. Do practice these questions which I gave you right now. Each and every question is super important question. So do practice, because one essay, one shot is compulsory here. That means 4 marks, 3 marks minimum I am saying. So 7 marks compulsory you are gaining from this session. So do practice all these questions. So thank you so much for watching. I'll see you all in the next session. Do practice, keep practicing and keep loving maths and also math facilitator. Thank you so much. Take care. Bye bye.